Hello, geometry. 5.2, congruent polygons. We're going to go from the triangles to the polygons here. The essential question, we're given two congruent triangles or other shapes. How can you use rigid motions to map one triangle to the other triangle? Remember from chapter 4 that these three options right here, these are called rigid motion because they maintain, this is on page 128, the size and shape of the images. So translations, reflections, and rotations, those are referred to as rigid motions. Okay? Dilation is a non-rigid because it has the same shape but different sizes. Eventually we're going to get to that. That's going to be called similar. Non-rigid transformations require similar objects. Okay, so this is the same thing that we saw similar in chapter 4. They say describe a composition of rigid motions that map a triangle ABC to triangle DEF. That would prove that these are congruent triangles when you can do that. Okay, so this could be a reflection and then a translation. So we could reflect it over the x-axis, and then we could translate it 3 right. Okay, so that would be a description of how we can prove these are congruent figures, is we can say, hey, these are rigid motions that take one object to the other. This looks like it could be a rotation, 180-degree rotation. Okay, so what we're seeing here, we're going to jump over to page 130. Our vocab here is referred to as corresponding parts. So, corresponding parts are the angles and sides that would overlap if you moved one object to cover another using rigid motions, rigid movements, let's say that. Okay, so it'd be the angles and sides that would overlap if you move one object to another to cover another using rigid movements. Okay, so here we have, let's go down the notes and I'll come back up to these. If I had 3 triangles, 2 triangles, sorry. And I could tell this is just a translation. I could take this triangle A, B, C, and I could translate it and cover up triangle D, E, F. Okay? So that means side AB corresponds to side DE. They are the same length, they're the same size. So I'd say AB is congruent to DE. That's a list of corresponding parts. Okay, so that's one side. BC corresponds to EF, so that has to be the same length as that. So I would say BC is congruent to EF. I'm putting the segment symbol on there because these are congruent. If I left it off, it'd be talking about the length, and they would be equals. So the lengths are equal, the segments themselves are congruent. Final one, AC is congruent to DF. So segment AC is congruent to, that's an equal sign with a squiggle on top, to segment DF. So those would be the corresponding sides. Those are the corresponding sides. We can also do corresponding angles. So angle A corresponds to angle D. So I'd say angle A is congruent to angle D. Angle B is congruent to angle E. That's its corresponding part. Angle B is congruent to angle E. And the final one, you notice I'm using different arc lengths here. Angle C is congruent to angle F. So these are our corresponding sides. Sorry, angles. Corresponding angles. Okay, so that's how you label all your corresponding parts and corresponding sides. In a triangle, you would have 6 of them. If you're talking about a quadrilateral, you're actually going to have 4 sets of corresponding sides, 4 sets of corresponding angles, 8 of them, okay? So here are the reflexive, symmetric, and transitive properties showing up again. Reflexive property for any triangle, triangle ABC, and triangle ABC is congruent to triangle ABC. Okay, makes sense. Symmetric property, if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. So same properties we've been seeing, just now they're putting it into triangles. So they call them the properties of triangle congruence. They apply to triangle congruent stuff as well. Third angles theorem. If 2 angles of one triangle are congruent to 2 angles of another triangle, there's the angles again, then the third angles are also congruent. Okay? So if you have 2 triangles and you know this is 20 degrees, that's the right triangle. And that's that, and that's 20 degrees. Okay, so if you're given this triangle with 20 degrees, 90 degree, 20 degree, 90 degree, both of the remaining angles are, well, that's 90, so these have to be complementary, so they would both have to be 70 degrees. So that's all that's saying is if 2 angles are congruent, the third angle has to be congruent to the other one as well. Okay, we're moving right along. Okay, so here we go. Identify all pairs of congruent corresponding parts, then write another congruent statement for the polygons. So they've said triangle PQR is congruent to triangle STU. And they've given us diagrams. You really don't need diagrams. You can take all your information from this object right here as well. But PQR is congruent to triangle STU. So we're going to write all our congruent parts. So let's start with the sides. So I'm going to say PQ is congruent to, so P went from the 3 sides there to the 2. 3 sides to the 2. So 3 sides to the 2, ST. So the first one, PQ. You got that one done. Keep going around the triangle. QR is congruent to, so Q went from 2 to 1. So 2 to 1 has to be TU. We'll keep going in the same direction around. And then RP, notice the order in which I'm putting these is staying consistent. R goes from 1 to 3. So I'm going to say US. I'm not going to say SU, I'm going to say US. Now notice you can get the same thing from this symbol here. PQ has to match ST. There's our first one. Okay. QR has to match TU. So I can get it from the last 2 letters. And then RP has to equal US. Then I go from the last one to the first one. So first and second, second and third, third and 1. So we get the same things there. When we do the angles, you have to still match them up the right way. P has to go with S. So angle P is congruent to angle S. Angle Q is congruent, that's the second one, so it has to be congruent to angle T. And then angle R has to be congruent to angle U. So these would be your sides. These would be our congruent angles, their corresponding parts. Write another congruent statement. What you do there is you just have to mix up the order for PQR and STU, but make sure they stay, you do the same order there. So I could go triangle, instead of starting with P, I could start with Q. Triangle QRP is congruent to triangle TUS. So that could be an option. There's more than one option. I could start with triangle side R. Triangle RPQ is congruent to triangle UST. So all of those would work. Okay, any of that would work. Okay, a quadrilateral, you just got to go through and match up all these sides. Okay, so again, I'm going to do it from here. So I'm going to do the first two, go up here. AB is congruent, so 1 and 2 has to be congruent to E and F. Then I'm not always trying to look at this diagram and try to figure out, okay, where are things here. So AB is congruent to EF. Go back, so the first two are done, go to B and C. BC is congruent to FG. So BC is congruent to FG. I'm going to label them on here, then I have it. Okay, 1 and 2, 2 and 3, 3 and 4. CD is congruent to GH. So CD, GH, the big one there. And then the last one and the first one, so DA is congruent to HE. Okay, so there's your sides. The angle should be the same. Angle A is congruent to angle E. Just go down the row. A to E, B to F, C to G, D to H. So angle B is congruent to angle F. Angle C is congruent to angle G. Angle D is congruent to angle H. Get sloppy over there. Your new congruent statement, I would just move it down a row. I would say BCDA is congruent to FGHE. And you can write one that's different. Maybe start with C and go backwards. CBAD is GFEH. Lots of different possibilities you can do with that one. Okay, we got some work to do here. Okay, find the values of X and Y. So it's saying these two triangles are congruent. So it looks like 15 has to equal 3y plus 9. Because XZ would match up with RT. XZ matches up with RT, which is the same as ST, because it's isosceles. So 3y equals 6, y would equal 2. Minus the 9, divide by 3. This angle would match up with that one, so 2x minus 20 equals 30, because y corresponds with s. Y corresponds with s, so they have to be equal. Add the 20, so 2x equals 50, x equals 25. Got it. Okay, here I have angle A. I have this 108. This is an angle because you know the degree mark there. A corresponds with E, and E is 108. So 60 plus 8x equals 108 minus the 60. 8x equals 48. Divide by 8. So x equals 6. Okay, G corresponds to C. G corresponds with the C, so 8y minus 3x has to equal 62. So 8y minus 3x has to equal 62. I got two variables, but I do know what x equals. Woohoo! So 8y minus 3 times 6 equals 62. 8y minus 18 equals 62. Add the 8y over, so 8y equals 70, 80, and y equals 10. Okay, so you had to find x first. Once you found x, you can plug it in and then find the value of y. Exercise 5 and 6. Show that the polygons are congruent. Explain your reasoning. Okay, so we're going to go through all our correspondence parts here. Okay, we're going to explain our reasoning here. So some of our givens, we know that AB is congruent to CB, and that's given from the diagram. We know AD is congruent to CD. That's given from the diagram. Here, you see this BD, this is our third side, so I need 3 sets of sides, 3 sets of angles here. So I'm going to say BD is congruent to BD. This one comes from these properties of triangle congruence. That is the reflexive property. You'll see that in your assignment as well. Okay, so I'm going to say this is the reflexive property. angle A is congruent to angle C. That's given. That's from the diagram. Okay, I can't say angle D here because there's two angle D's. So I'm going to say angle ADB is congruent, ADB, there's the 90 degrees, to CDB. And that's because we have perpendicular lines. We have a 90-degree angle there, perpendicular lines. So those two are angle and those two are equal. We can assume that these two are equal because of the third angles theorem. Third angles theorem. If two angles of a triangle are congruent, the third ones have to be as well. So I'd say this is angle, I want angle ABD has to be congruent to CBD, angle CBD, and that's the third angles theorem. So we've shown that the polygons are congruent by stating all their corresponding parts. Okay? So this instruction here, you have to state all the corresponding parts. So we can say then triangle ABD is congruent. ABD is congruent to, okay, A goes to C, so triangle C. B goes to B, D goes to D, triangle CBD. So there's your congruent statement, and we've explained our reasonings as we went along there. Okay, number 6, obviously this is all given. There's nothing here you have to assume. I wanted to go over this where you had a shared line there. So our congruent statement here, I would start at N. So I'd say N, M, L, K. So pick a direction. So you start here, and I'm going to go this way. Now, what corresponds to N? It looks like this is a rotation of the two objects. So L goes to H, N is going to flip around, go to J. So I'm going to say that's J. I want to cross to the two angled ones. That's I, H, G. And you can list all your corresponding parts to that if you really want to write that down. Exercises 7 and 8, find the measure of angle 1. And measure of angle 1 is down here. Okay, so this one is not, I know it has one line there, so you're like, hey, that's 33 degrees. Not necessarily, but we can assume that this one is 33 degrees. Okay, so this angle right here, I want you to look at this triangle here. Okay, if we can find this angle, or this angle, then we can take it 90 minus that, and we can get that one. Okay, hopefully you see that. So if that's 33 degrees and that's 90, 33 and this one have to be complementary because you have a right triangle. So 33, I'm going to call that x, plus x has to equal 90. So in that case, that's going to equal 57 degrees. That's 57 degrees. Now look what happens. You know angle 1 is 90, the total angle minus that one, so that's 90 minus 57, guess what you get? 33 degrees back. Okay, so that one right there is going to be 33 degrees as well, so it did match that. On this one, measure of angle 1. So here's 54. These are vertical angles. So that makes this 54 degrees as well. Okay. Now, if this is 54 and that's 54, this angle equals this angle. This is the third angles theorem. We know this one has to be 80 degrees. So we can take 180 has to equal the measure of angle 1. Let me get a darker color for you. Plus 54 degrees plus 80 degrees. So measure of angle 1 plus 134 equals 180. Minus the 134, and you get 46 degrees equals the measure of angle 1. So it would be 46 degrees. Okay, so that's how you're using those theorems. These are starting to get a little bit more involved. Parallel lines may come back into play as well at some point. But getting lots of diagrams here and trying to figure out where is that angle measurement and how can you get there using vertical angles, alternate interior angles, alternate exterior, corresponding angles, linear pair, all those things would come into play. So that should cover it right now. Tony's coming in to clean the room, so I will wrap this up. You want to come say hi, Tony? No one, I'm just recording a lesson for geometry.
Get it done.
He didn't hear yet. Oh, you come show your face. Okay, you got to remember what you look like when you're gone.
Get it done.
There we go. Words from Tony. We'll see you in class.